Today is Friday, December 11th. Please pause the video now and complete the Do Now. Today's objectives are students to be able to complete the steps to prove the isosceles triangle theorem and its converse. Students to be able to identify characteristics of an isosceles triangle, and students to be able to solve for unknown measures of an isosceles triangle. Let's go ahead and begin. Today's lesson is titled Isosceles Triangle. This is Unit 4, Lesson 6, the last lesson in our unit. First, let's do a brief review of the triangle parts theorem. The triangle parts theorem said, or stated, if one side of a triangle is longer than another side of a triangle, then the angle opposite the longer side is larger than the angle opposite the shorter side. Basically, what this is stating is that if we identify the largest side, for example, out of 16, 8, and 18, our longest side 18, the angle opposite that side is our largest side, so A would be our largest side, and the angle opposite our shortest side, in this instance 8, would be our shortest angle. That being said, we can go ahead and label or order our different angles from smallest to largest or largest to smallest. If I wanted to do largest to smallest, I would start with A, put my smallest angle last, and then put my middle angle, or that not identified thus far, as my middle angle. So therefore, from largest to smallest is angle A, angle B, and angle C. Again, this is a review of the triangle parts theorem from our previous lesson. Let's dive deeper into isosceles triangle. An isosceles triangle, as stated before, is a triangle with at least two congruent sides, or two sides that are congruent. Remember, the key word here was at least. The reason being is that the triangle can have more than two congruent sides, for example, in an equilateral isosceles triangle, but it cannot have less than two congruent sides. It must have at least two congruent sides to be congruent. Well, a unique thing that we're going to learn today is an isosceles triangle has two base angles and one vertex angle. Here I have labeled my base angles, B and C, and my vertex angle, which is angle A. A unique thing about my base angles is that my base angles are always congruent. Therefore, if an isosceles triangle has two sides that are congruent, then its two base angles will also be congruent. That being said, we can go ahead and identify that line segment A and B and A and C are congruent to each other, and our base angle B and C are also congruent to each other. Let's go ahead and move on. Now we're going to look at the vertex angle of an isosceles triangle theorem. The vertex angle of an isosceles triangle theorem states that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base. So, what we know about angle bisectors is that angle bisectors bisect an angle into two congruent halves. For example, here we see that line segment TR is bisecting angle T in order to create two congruent halves. A unique thing about the perpendicular bisector of an isosceles triangle is that perpendicular bisector, because it is perpendicular, the angle bisector is perpendicular, that means that bisector also cuts that base into two congruent halves. So not only are our two sides congruent because we have an isosceles triangle, but when we do the perpendicular bisector, our two bottom halves are also congruent to one another. Therefore, QR is congruent to RS, and QT is congruent to TS. We can also go ahead and identify that angle QTR would be congruent to angle STR, as well as, because it is an isosceles triangle, that angle Q would be congruent to angle S, and our angle TRS would also be congruent to TRQ. These are all the things that we can identify from the vertex angle of an isosceles triangle theorem. Kind of cool. Let's go ahead and look at another theorem. The isosceles triangle theorem, its converse, and its corollaries. The corollary of the isosceles triangle theorem is pretty simple. It tells us if a triangle is equilateral, so if all three angles are the same or congruent, then it is equiangular, which means all three angles are also congruent. The corollary of the converse of the isosceles triangle theorem tells us if a triangle is equiangular, so if all the angles are congruent, then all the sides would be congruent, as you see here. Let us remember that the converse of a theorem is nothing more than switching the hypothesis with the conclusion, and that's how we get these two. Let's go ahead and work out our first problem. This problem asks us to apply the isosceles triangle theorem. The isosceles triangle theorem basically told us that if we have two congruent sides, well then our base angles are also congruent. That being said, we are being asked, what are the measures of the base angles and the vertices of the isosceles triangle theorem? Well, we know we have two congruent sides, AB and CB. Because those two are congruent, we can assume that our base angles are also congruent. So, angle A is congruent to angle C. Well, we're being asked to find the measures of the base angles, so what we can do is go ahead and equal those two equations together, solve for x, and then plug it back in. So that gives us 4x plus 9 is equal to 8x minus 15 plus 15 plus 15, 4x plus 24 equals 8x minus 4x minus 4x, 24 equals 4x, divide by 4, x is equal to 6. Now I can go ahead and plug this. Because I know my two bases are congruent, I can plug it into either or. So I'll do a 6 plus 9, 24 plus 9 gives me 33. I'm just going to double check the bottom one just to show you that congruency. That gives me 45. Oops. There we go. That gives me 48 minus 15, which is 33, and thus I have my two congruent base angles. But I'm also being asked to identify the vertex angle, or the measure of angle B. Well, a unique thing that I know about triangles is that all the interior angles must equal to 180 degrees. So when I add angle A plus angle B plus angle C, I have to get 180 degrees. Well, if I know that A and C are equal to 33, then what I can go ahead and do is solve for angle B like this. So that gives me 66. Okay, minus 66. Plug that into my calculator. Which shows me that my measure of angle B is equal to 114 degrees. And that's how I solved for the base angles and the vertex angle. So what I did here was identify my relationship between my two congruent sides, which gives me two congruent bases. I equaled the bases together, solved for x, plugged x back in to find the base angle measure. If I know that angle A is equal to 33, I can reasonably assume that angle C is also equal to 33, but I can go ahead and plug it in just to double check. And then because I know all the interior angles of a triangle equal to 180, all I have to do is subtract 33 from 180, another 33 from 180, and that gives me my remaining measure of my last angle, my vertex angle, and that is 114 degrees. Let's look at the next problem. Oops. Let's see. This is my next problem. This problem is asking me to apply the vertex angle of an isosceles triangle theorem. Well, basically what I can see here before even reading the problem is that I'm given an isosceles triangle and I'm given a angle bisector which bisects angle ADC or angle D into two congruent halves. Given this information, I can hopefully solve for various different measures, and let's begin. The question asks, line segment ABD is the angle bisector of ABC. So we know that DB bisects the angle ADC into two congruent halves. If the measure of ABD is, and then we're given the equation for that, let's go ahead and plug that in. So if ABD is 32x minus 6, what is the value of x? Well, there are two ways we can go about solving this problem. We can either go ahead and add our equation plus 90 equals 180 because we know that this is 90 and we know that our angle ABD and our angle CBD are supplementary because they share that line. So we can add those together equal 180 and solve for x. Or what we can do is because we know they are supplementary, then we know that each angle together has to equal 180 degrees. If we know that 90 degrees are already taken, then we know that the other half has to be 90 degrees because 90 plus 90 is the only way we can get 180. So we could do 32x minus 6 equal to 90 and thus solve that way. Either way is completely fine, but I'm going to go ahead and do the easiest route, and that is 32x minus 6 equals 90. I'll go ahead and move my 6. This gives me 32x equals 96. So I want to divide my 32 to isolate my x. So divided by 32 gives me x equals 3, and thus x will equal 3. So all I'm being asked to identify is what the value of x is. Okay, let's look at another type of problem we might encounter. We're being asked to apply the vertex angle of an isosceles triangle theorem once again, and we're given specific information. More specifically, we are told that AB is equal to 21 and CB is equal to 2y minus 3. What is the value of y? Well, remember that the vertex angle of an isosceles triangle theorem gave us a lot of different information. It told us that ABD would be cut into two congruent halves. It told us that AD and DC would be congruent to one another, but it also told us that AB and BC would be congruent to each other, as well as angle B being congruent or equivalent to its other side. This is all the information we got from the vertex angle of an isosceles triangle theorem. The big thing that applies here is that we know that AB is equal or congruent to CB. So what we can actually do is do 21 equals 2y minus 3, and then do an algebraic process. So plus 3, 24 is equal to 2y divided by 2 gives us y equals 12, and thus we have solved for y. So that is one way to go about solving that kind of problem. Let's look at another type of problem we might encounter. This is asking us to apply the converse of the corollary of the isosceles triangle theorem, which basically told us if a triangle is equiangular, then it is equilateral. So what does that mean? It says the measure of BAC is equal to 5x minus 20. What is the value of x? Well, what we learned in the converse of the corollary of the isosceles triangle theorem is that if all these are equiangular, they're all congruent, then that means that all our sides are congruent. So if angle A is equal to 5x minus 20, so is angle C and angle B. And what we also learned is that all the interior angles of a triangle add up to 180 degrees. So what we can ideally do is do 5x minus 20 plus 5x minus 20 plus 5x minus 20 is equal to 180 degrees. And so in that way we can solve for x, and we can do that by adding all of our x's together. So this gives me 15x. And then I'm going to add all my 20s together. Which gives me negative 60. Then I'm gonna do an 80. Then I'm gonna go ahead and add 60 to both sides. 180 plus 60 is 240. So I get 15x equals 240 divided by 15. Divided by 15, which gives me the x is equal to 16 degrees, and thus I'm able to solve the x value. And if I want to plug that in to solve for each angle, I could go ahead and do so, but I'm not actually being required to do so in this question, so that is all I need to do. Okay, so let's review. Today we went over different types of theorems. The first was the isosceles triangle theorem, which basically told us that we know that isosceles triangle has to have at least two congruent sides, right, in order to be an isosceles triangle. Well, given that we have two congruent sides in an isosceles triangle, that means, or from that, we get the isosceles triangle theorem, which tells us that our base angles, in this instance angle B and angle A, are also congruent. So those are two things we can determine from the isosceles triangle theorem. More specifically, the AC is congruent to CB, and the angle A is congruent to angle B, our base angles. Okay, then we also learned about the vertex angle of an isosceles triangle theorem, which told us that the bisector of the vertex, so the bisector cuts the vertex, in this instance angle C, into two congruent halves in our isosceles triangle, is perpendicular to the base. So what that basically means is that while it cuts that in half, it also cuts our base angle into two congruent halves. And so therefore we can go ahead and identify, I'll go ahead and zoom in just so you can see it a little easier. We can go ahead and identify that these two are congruent. So say this was line segment CD, which was a angle bisector and perpendicular bisector, then that means that from that we can determine that AD is congruent to DB. And what we can also determine from this is we know that AC is congruent to CB, and we also know that this angle would be congruent to this angle, so let's call this ACD is congruent to CDB, or sorry, I need my C in the middle, so I'll call it BCD, okay? But I also know one more thing, and that's that this angle is congruent to this angle. So I know that ADC is congruent to CDB, and I also know one more thing, and that is because I have two congruent sides, I also know that my base angles are congruent, so that means that angle A is congruent to angle B. And those are all the different things and relationships that I get from the vertex angle of an isosceles triangle theorem. Now let's look at the corollary of the isosceles triangle theorem. This one tells us that if something is equilateral, so all the sides are equal to each other, then all the angles will be equal to each other. So if equilateral, then equiangular. So basically what that says is here we know that all these sides are congruent to each other. So that would look like AC is congruent to AB, which is congruent to CB. But it also means that our sides are also congruent to each other, because if it's equilateral, then it's equiangular. So that would look like A is congruent to B, which is congruent to C. And these are all the different relationships that we can determine just by knowing that we have an isosceles triangle. These are our different glossary terms that we looked at. We reviewed isosceles triangle, angle bisector, base angle of an isosceles triangle, vertex angle, and equilateral triangle. And that being said, today is a Friday, so you don't have to work on independent practice, even though I have posted some example problems that you can go ahead and view. But other than that, this weekend I would just recommend studying for the Unit 4 exam, as that exam is next Wednesday. I have posted the review guide in the classwork tab under Friday, and please reference those practice problems as always, because those will be most helpful in the exam. If you have any other questions or concerns, please do not hesitate to reach out to me. I'm always here to help. Bye guys.